Okay, class, let's continue with number 23. And again, they ask us to use the composition cancellation equation to verify that f and g are inverse functions. Okay, so for part one of this particular solution, we are going to look at the composition of f and g. And let me use a thinner x equals f of g of x. Okay, and then when we do that, we're typically going to get 2 times the cube root of x minus 3 cubed over 8 plus 1 minus 1 plus 3. Okay, and we do that, we're going to get 2. And these two cancel out each other. Okay, so that's going to be 2 times the cube root of x minus 3 cubed divided by 8 plus 3. Take it a step further. I'm going to break this portion up here. I'm going to break it up, and then I'm going to say 3, the cube root of x minus 3 cubed divided by the cube root of 8 plus 3. Okay, and then when you do that, what you're going to get is 2 times this this cube root of 8 is going to be 2, right? So it's going to be 2, and then for the numerator, you have a power raised to power 3 and you have a radical 3. They cancel each other out, so you're left with only x minus 3 plus 3. And then these 2's cancel out each other, so you're left with x minus 3 plus 3, which equals x. Okay, so for the second part, we want to look at the composition of, again, this is not a 0. Okay, that's just showing you this composition. That's a symbol for it. Okay, equals g of f of x. And when you do that, what we're going to get is we're going to get 2 times the cube root, okay, x minus 1 x minus 1 plus 3 minus 3. Okay, and we're going to get to the cubed, and that's going to be over 8 plus 1. Okay, when we do the math, we know that these two go to 0. Okay, and I'm just going to rearrange this now to be 2 to the cube times the cube root of x minus 1. Okay, and that's also going to be cubed divided by 8 plus 1. We know here that the 8 here and the 2 cubed, they cancel each other out, and we're left with, since we have a power here of 3 and a radical of 3, we're left with only x minus 1 plus 1. This plus 1 here, and we get an x. Okay, so we just verified that our f and g are inverse functions because they both equal to x. Okay, now let's go to another problem, number 25. So here they're asking us to sketch, use this graph. They want us to use this graph here, y of x, to sketch the graph of the inverse function, okay, of f of x, and then use the graph to determine the domain and the range of each function. Okay, so the idea point here is to make things a whole lot quicker. Choose at least about 3 to 4 points and then you're going to swap the coordinates. Okay, and I'll show you what I mean now. So for this particular, so we have a coordinate here, which is what? -1, 5. We have another coordinate here, which is 0, 3. Okay, and we have another coordinate here, which is 3, -3. So the idea, and this is for your function. Now for your inverse function, you just swap this is our x. Let me just use a different color here. This is our x coordinate, and this is our y coordinate. This is our x coordinate. This is our y coordinate, x coordinate, y coordinate. Now you want to swap them. So for this one, now it's going to come 5, -1. Okay, and now you have 3, 0, and now you have -3, 3. And this is going to be your it's going to be an inverse function, the points. Okay, that's the points now. So we want to plot this. This is what we're going to plot right here. Okay, so 5 and -1 out here, 5, and this is right here, -1. Okay, and then we want to plot 3, 0, 1, 2, 3, right here, and then -3, 3. And I want to use a different color. This is my 0 here, 1, 2, 3, 1, 2, 3. And that's, I just draw a line. Okay, and that's this is my inverse function right here. Okay, now they want to ask us the domain. So keep in mind that your domain is always your input along the x-axis. Okay, so let me come down. Let me see if I can come down here. Sorry, let's come down here. So my domain, in this case, so the domain for the f of my function, this function right here, equals, and that's your input, right? It's going to be an input, and that's going to be what? Since these are closed circles, it's going to be -1. And by us having this arrow down here means it goes on forever, and that's going to be a positive infinity. And the range is going to be the y value, right? And the range in this case is going to be, it starts off with and that's along the y-axis. As I said, the range is along the y-axis. The domain's along the x-axis. So it's going to be -infinity because it's starting from here. And it goes all the way up to 5. Okay? And that's a closed bracket because this is our 5 right here. This point right here is -1, 5. Okay? Now, once you know this, it's very simple. You just cross multiply these. When I say, I don't mean to cross multiply, I'm sorry. That's the wrong term. You just swap them now. This is your domain. So you just want to swap. This is your domain now of your inverse function. And that's going to be, and let me just move this down here. So just move this down a little bit. Okay. And this is going to be your domain. Use another color. And that's just going to be negative infinity, comma 5. And then your range is going to be, the range for your inverse function is nothing more than this right here. It's the domain of the function itself, negative 1, comma. Okay, so that's your answer right there. Okay, so let's take it a step further. Uh, just erase this part right here. Let's take this a step further and say for number 27, we have this function here. Again, take your points. If you want to draw the inverse function, take the points from your original function and just take 3 points. So here we have our first point. We're typically going to have this right here is going to be negative 2, comma negative 2. This point right here is 0, comma 0. And this point right here is going to be 2, comma 2. You swap them. This is for your function itself. You swap them. Again, negative 2, negative 2, 0, comma 0, and 2, comma 2. And this is your inverse function. Okay. Now I can come here and plot. This is my 0, 0 right here. I can plot another one, negative 2, comma 2, 1, 2, 1, 2. So we'll be right here. And then we have positive 2 and positive 2 and 2 right here. So it looks something of this nature. If we were to draw this graph, it's going to look something like this. Okay. And your domain, again, okay, for the f function, for this part right here, is going to be negative 4. I'm sorry. I'm deeply sorry. I'm looking at a different problem. In this case, since we have these two arrows right here, it's going to be negative infinity, positive infinity. Okay. And our range is going to be, for our f function, is going to be negative infinity, comma, positive infinity. And again, all you have to do is whatever your domain is for your original function is going to be the range for the inverse function. And that's going to be negative infinity to positive infinity. And then I have here the domain of our inverse function is going to be the range of the function. And that's going to be negative infinity to positive infinity. Okay. Okay, let's take it a step further. I'm going to go to number 28. Okay. So here again, they're asking us here to use the graph of the function to sketch the graph of inverse function and use the graphs to determine the domain and the range of each function. Again, my points here, start from here. Okay, that's negative 4, comma 5, right? This point right here is what? 0, comma 3. And this point right here is going to be 2, comma 4. Again, this is your f function, right? Now, I want to swap them. So now I'm going to get 5, -4. Okay, this is 3, 0, 4, 2. And this is going to be an inverse function. Okay, so I can come down here and I can graph this. And when I graph this, it's going to look similar to 5 negative. It's going to be 5, -4. 5, -4. 1, 2, 3, 4. Something like this. 3, 0. Okay. 4, 2. That's 4, 1, 2. Okay. So when you do that, typically you just plot those points: 5, -4, 3, 0, 4, 2, and then once you draw that, so your domain for your function itself, right? This is my function. This is my inverse function here. Okay, and it looks like this. Okay, so my inverse function is going to be, my domain of my function itself, it's going to be 4, because again, your domain is along the x-axis, 2. That's the range. The domain is how far is that graph along the x-axis. And since they are dots, you have a bracket here. The range of our f happens to be along the y-axis now. Okay, so we start off with what? A -5, because you're right here on the y-axis. That's the y point. This y point right here. And then the maximum point along the y-axis is 4, 4. And that's also a dot. And it gives us a bracket. Okay, so now if you want to be able to find the domain of the inverse function, is nothing more than the range of the function, which happens to be -5, 4, and then our range of the inverse function happens to be 4, 2. Okay, so I'm going to stop here, and I thank you very much for your attention. Again, if you follow these principles, you will not get lost. Okay, thank you very much. Bye-bye.